Hello, I'm Colton, and welcome to part 2 of 2 of this video overview of CPQ, a logic mod that I'm working on for Quake 1. In this part, we'll be looking at more of the technical specifics of CPQ, and we're going to start with an overview of CPQ, going through some of the core entities that make up the mod. After that, we're going to take the map that we played in part 1, CPQ Showcase, and open it in an editor, and examine every piece of logic that was set up using the CPQ entities. Now, it's important to note that this video will be going through some very technical elements of Quake 1 mapping, and because of that, I won't be going into detail on some of the core Quake 1 mapping concepts that I refer to. If you're interested in learning about Quake 1 mapping, I've put some links in the description below. So let's get started by looking at how CPQ works. How CPQ works is the entire system is based around the concept of how an actual computer works. And I won't get super technical here, just a slight bit technical. A central processing unit, or a CPU, hence the name of the mod, CPQ, operates off of the fundamental aspect of what are called registers. A register is effectively a container of data. It can be a number, it can be a string of characters. So how CPQ emulates that is we have this concept of the register in CPQ as info_register. And currently in CPQ, a register is a holder of a number. It can be a float, it can be an integer. It is a number. In addition to the register, we have three other types of entities in CPQ. We have an entity that is an operator, we have an entity that is an expression, and then we have entities that use a register, right? So let's dig into those real quick. We have our register. The operator is basically an entity that lets us do an operation against that register, right? So if I wanted to add to a number, subtract, multiply, divide, all the basic kind of mathematical operations, we would use that to change the value of a register. One of the ways that CPQ emulates a CPU is that you can have two registers and do an operation on them and then store the result in a third register. You could do that in CPQ. Or you could have, let's say, the number 10 in a register, multiply it by 10, and store the result in that same register, overriding it. You can do either with CPQ. The third type of entity that we will be looking at are expressions. How you evaluate what's inside of a register, what that number is. And this is stuff like, is this number bigger than 5? Is it less than 10? Is it equal to 0, right? Ways of evaluating the number, and then sort of a branch of what you can do from that result. And we'll see more about that. And the last kind of entity is basically how you use that number. You can use it for positions in the world, which we'll see. You can use it to add health, add armor, all sorts of stuff. So to review, we have registers, which hold the data, operators, which change the data, expressions, which check the data, and users, which do something with the data. There are, of course, other utility entities that we'll use for logic purposes, but those are the four core entities that we'll be looking at. So with that overview done, let's dig into the map itself and start looking at how these were set up. All right, so we're actually not going to go in order that they were shown in the map. What I'm going to do instead is go through them in order of complexity. I feel like this will be easier to ramp up on how CPQ works. I don't want to kind of jump in the deep end because the actual the map room in the on the ship that the player starts in is actually kind of complex. So I want to go through the straightforward ones and then ramp up. So we're going to bounce around the map quite a bit. But if you've watched the playthrough, you will recognize these points. But I'll still call them out. So we're starting here with this secret side piece in the main base entrance, which I'll show without triggers so we can kind of see what it is, just so people recognize it. This is you enter here, and off to the right is this this health door that only opens if you're at a certain amount of health. So this will be a fantastic way to show off CPQ. So primarily how we'll drive the execution of CPQ entities are through trigger brushes. Unsurprisingly, that's how almost all of CPQ gets triggered. Just like most logic in Quake, player walks through a trigger or somehow otherwise presses a button to hit that trigger, something happens. So we do the same thing here. So let's look at the various elements that we have in this this instance of our arrangement here. Oh, my grid is huge. Okay, so we have the trigger multiple. This means that every 0.2 seconds, or ticks or seconds, I believe it's seconds, the player is in this trigger brush. It will trigger this entity, the trig set health. And I'm not going to necessarily call out what everything is named, because that's just confusing. But I'm going to call out what it's targeting. So the trigger is targeting a set register trigger. Most of the triggers in CPQ, most of the entities in CPQ are the base class of trigger. So mostly everything is a trigger of some sort. That way we can chain logic from one trigger to the next. So the trigger multiple looks at a set register trigger. This is a pretty straightforward entity. This basically sets the register that it's told to with a certain value. One of the new fields that lots of entities have in CPQ is this concept of the operation type, and we'll see this quite a bit. Setting the register and using the register or doing an expression, all will check a certain operation type. So let's dig into that. So this trigger will trigger the set register trigger, and we have these target registers. Here is our register. As we discussed, a register is a container of data, and CPQ, a register is a container of numbers. You can actually define what the starting value is of the register. It actually should be 0 because they should have something in them. It will default to 0 when the game starts, but it's just good practice to have it. You could also put any value you want here. This could be 50 if you want it to be, but it's not. So this will set. This is the reg _ player _ health _ door. I try to be pretty good about naming my entities. Set register obviously has that as its target for a register, and it also has the operation type. So here we have about 22 different operations right now, 23 or so. So what this is doing, what set register is doing, it is taking, based off of the operation type, that's how it will set the register. So in this instance, it's being told, because operation type is 0, and at some point I'm going to go through and change these so 0 is not an operation, because that's not good style. But, this is in deep development. So when operation type is 0, we take the target's health. By default, a trigger, if a trigger has no target, and when I say target, I don't mean target as in the actual target of the trigger. We have these target entities, basically, which you can target other triggers, you can target enemies, but if there is no target passed, no entity target passed, it is assumed it's the player, which is the activator of the trigger, or the chain of triggers. I apologize if this is in the weeds, but if we're going to dig into it, we kind of have to get into the nitty-gritty of it. So in this instance, let's walk it through. We have the trigger brush, which is triggering set register, which is being told to use the target health, in this case of the player, and put that into our register. So player walks up to this trigger. Let's say they have 100 health. This trigger gets activated, chains to set register. This then sets this register to a value of 100. Pretty straightforward. But we're building a chain of triggers. So the trigger that set the register has a target of expression check health, which is our second or our third main entity, which is one of our core types of triggers, the evaluation. It's a Boolean expression. The names of all these entities might change over development, but the concepts will stay the same. So what this is doing, this is checking the value of the register to see if it meets the Boolean expression or not. So here we have, same as with our setting, we have different options for what kind of operations we can do. In this instance, we have 8 of them, but we want to see if it is less than or equal to 50. You'll see a lot in CPQ, count is where almost exclusively used for storing data. As we saw on the register itself, count is its current value. When we're checking the value of a register during gameplay, it's looking at the count value of the entity. So we use that for expressions as well. We use count if we want to see if a register is less than or greater than a certain value. We could also compare 2 registers. We have a spot for that, right? We could actually have register 1, register 2, and it will check to see if one is less than the other one, but we're not doing that. So here, we're checking the reg_player_health_door, which is populated by set register to be the current health of the player. And it is checking that and is seeing if it is less than or equal to 50. So what we're saying is we want this next trigger to happen if the player's health is less than 50 or equal to 50. And we have this concept of kind of, because it is a Boolean expression, it's true or false, so it's 1 or 0. It will do something if it's false and something if it's true. And that's what we have target expression true and target expression false. This is just basically, this is treated as a normal Quake target, or sorry, a normal Quake trigger. Meaning this could be a door, this could be a button, this could be anything. Anything that could take a trigger, this can target. This will just, this can be treated as though it is targeting a trigger, and it will execute that trigger. We also have the ability to do messages, the in-game messages that pop up. So we can both do a message and do a target trigger if it is true or false. So in this instance, we have something, we're doing a target if it's true, and we're targeting door_health, which is the door right here. So, walk it back. Player walks in the brush. This trigger sets this register to its current health. This then triggers the expression to see if their health is less than or equal to 50. If it is, this door goes down. If it's not, we actually use the message expression false to say health not low enough, and that's what we saw in the playthrough. So let's move on to our next entity. All right, so we're going to keep going through the straightforward ones first. This is actually a extremely straightforward element because we're not actually dealing with registers. We're dealing with a modified class that already exists in Quake, the func button. Basically, what we've done, I've added the ability to, when a button has health, so in Quake vanilla, when a button has health and you shoot it, if you do enough damage to it to meet or exceed its health, it triggers the button. What we've done is we've added a filter for that. Currently, it's reg data. This will be changed as a field name. This is sort of a catch-all for my tests, but just to make it more clear. But basically, this just if you put in the ID of the weapon being used that you want to filter, it will only allow damage done by that weapon. And it is a bitwise OR, so you could do multiple. But in this instance, the axe is 4096. So in this instance, func button will only trigger. It will only do damage and take damage if that damage is being dealt with an axe. And we'll see more of that in our boss fight. So let's move on to the next piece. All right, so let's go to the other side of the base here. This one's gonna be a little more complicated, but that's fine because we want to kind of get a sense of how these get set up. So as we recall, this trigger, this area was activated if the player stood on this platform, looked at the console, and looked up. It didn't trigger if they were looking over here. It only triggered if they were looking in this direction and then up. So just like how we were setting health before in this trigger, we're now instead getting their angle, and we see this here. We're getting their target angle Y, which is their yaw, and then we're getting target angle X, which is their pitch. So yaw being looking left to right, pitch being looking up and down. Z is roll, but we don't really use roll in Quake, at least as far as I know. So we have 2 registers for this, one for the yaw, one for the pitch. Each of our set registers sets the according register. So we set the yaw, we set the pitch. We have 3 expressions here, 2 for yaw, 1 for pitch. And I'm doing this because my pitch can be, there's no upper bounds on my pitch. If it's greater than a certain amount, I don't care. I don't need to check against it. But what I do care about, or actually the inverse, there's no lower bounds. I do care if it's lower than negative 75. If it's lower than negative 75, then I know they're looking mostly up, and I don't care about any values less than that. However, for the yaw, I want it to be within a certain angle here. And so I need to do 2 checks. I need to do a minimum and a maximum check. So first I do the minimum. I check to see if it's greater than or equal to 85. And then I do a maximum to see if it's less than or equal to 95. Right? So I'm getting these, what's it about? That's 10 degrees here that it will be allowed. So I do that, so I give the player a little slap to play with. It wouldn't be super fun if you just had to lock in an exact yaw. That would be awkward. It would only really work if you wanted them to look exactly at something. I would like to look into ways of making this a little more friendly, because you have to know what the yaw and the pitch is of the player at this position. You just sort of have to just know what the pitch and yaw is to put in that information. But once you do that, it's actually quite powerful. And then once it's also good to know that we're starting to see these chains of expressions where we start with the yaw minimum, we then go to the yaw maximum, but only if we've met the yaw minimum, right? If we don't meet the yaw minimum, we don't keep going. We just stop. But if we do meet yaw minimum, then we check yaw maximum. If that's true, only then do we check pitch. So we're not doing unnecessary checks. And then it's actually that way we know that all 3 are true. And then because all 3 are true, meaning we met our minimum, we met our maximum, we met our pitch, all 3 are true, then we do the trigger, and we open the door here, and we open the door here for the buttons, for the pumps. Okay, so I'll keep doing the side pieces in the base entrance. The other kind of side element was this prisoner transfer. You press the button, the grunt came out, and he followed you around. He did not try and shoot you, and you had to bring him over to this position. What we're doing here is two new concepts that are introduced into CPQ. One is we are changing enemy behavior, and this is done through use register. So we see here all the different ways that you can use a register. The name use register is a little misleading, and it will probably get changed at some point to be more clear, because you're not necessarily using a register to do it. What you're doing is you're using a value, and that value could be hard-coded. In this case, we have a hard-coded value of 16. So in this instance, we are playing with the monster state. This is a CPQ specific state where you can make them blind to you, make them forget about you, or make them not shoot you but follow you around. This is something that will be in the documentation. It's not intuitive to know what 16 means. It would be in some kind of documentation. We might even make this even more simple at some point, so it's easier to understand. But so 16 basically means the target enemy will not shoot at the player, but will attempt to follow them. And as we can do with all of our triggers in CPQ, we are actually targeting an enemy. He is named Dog Very Yes because this was initially a dog that was chasing you around, but the dog's forward motion was so broad that it kept bouncing around and it didn't make a good thing to lead around. So he kept the name Dog Very Yes. Interestingly, and I definitely tried to do this just to, from a game design perspective. If he dies, meaning if you shoot him, then we do a target trigger failed, which is just basically telling you, hey, your transfer has failed, just to let the player know that they probably shouldn't have killed him because they were told not to by the message here. So that's the first half of this. The second half of this is over here. So this is the target, and we're using teleport destination for the target, and I'll explain why in a second. But here we have other entities for this half of it. One entity that we haven't really talked about yet is the concept of a timer. We have info_timer, which is a CPQ entity, and it does just what you think it does. It has a wait, so every wait seconds, it triggers the trigger that it's been told to. In this instance, we have trig set dog dist. Again, this was a dog before, so I don't want to change all the naming after I change it to a grunt. And that is a set register. So every 1 second, while this timer is active, it will set this register. And what are we doing with this register? This is reg dog distance, and we are setting distance from entity 1 to entity 2. So we have two entities defined. We have dog Very Yes, which is the name of our grunt up there, and we have point dog go, which is this. So what this is doing, it is taking the distance of two entities in world space. We have the distance of the grunt over here, and the distance. We have the point where the grunt is, and we have the point where the target is, and we're taking the distance of that, and we're getting that every second. So every second we are putting that value into the register. So just to be very broad, first second, let's say it's 1,000. And as the grunt gets closer, it's 900, 800, 600, 500, right? The distance between these 2 points is getting smaller and smaller. As you can guess, probably, we want to see what that distance is. If it's less than or equal to 60, meaning if they're right nearby, then we trigger a delay after 6 seconds, because as we recall, it takes a few seconds for this gate to close so the player can get out. Then we close the gate, and then we trigger. I think we actually triggered the secret when he reaches this. When this goes off, not only do we trigger the delay, but we also change the grunt's state again. But this time we're actually freezing them. 4 is to just freeze. That's why they just completely freeze. And again, that will be in documentation. So let's recap. Player comes up here, and we've actually set. We were kind of sneaky about this. We actually set the grunt to be pacified, meaning he won't shoot at the player, but we'll follow him around on this ramp. Not when he presses the button. We do this because I found when the player was up here, the grunt would actually shoot at them through the door. And obviously I could have changed the door so he didn't do that, but I like the player being able to see the grunt to know that there's someone in there. And that made me think some players might want to shoot the grunt back as soon as they open it because he's been fired upon. So we actually are a little sneaky, and on this ramp we pacify him. So we pacify him on the ramp. Player presses the button, which just opens the door. We start checking. So we actually turn on the trigger, the timer. I'm trying to make it a practice, and there are tools in CPQ that will allow this, where you can turn timers off and on, because you don't want timers just running in the background. If you have too many timers running, you might actually see some performance hit. especially if they're all kind of stacked. But that's its own discussion about timers being stacked on the same tick. So I turn on the timer, so because I will only care about it once the door is open, and then this timer goes every second, sets the register with the value of the distance between where he is and where he should be, and as soon as that value is less than 60, we freeze him, and then we hit the relay, which closes the door in 6 seconds. So hopefully that made sense, and we can kind of see how we start to chain different pieces together. And let's move on to I think the pumps are the next thing. Let's do that. Okay, so now let's check out the pumps of the base entrance that we saw during the playthrough. This is a pretty beefy set of entities, so stick with me as we dig through it. But let's start by talking about what this is trying to accomplish. As we remember from the playthrough, there are these buttons on either side that get exposed from the platforms. Pressing these buttons increases these gauges, and then each of these gauges also increases the kind of master gauge over the door. Each of these gauges is its own is meant to represent one of the pumps. These are the pumps. I'm not sure I made that super clear in the brushwork, but here we are. So each gauge is also a register. And what I've been trying to do, and hopefully what you can see in this kind of overview, is I've tried to keep the entities near the objects that they modify or that they're a part of. So it's easy for other players or other mappers to kind of follow your logic, sort of like documenting your code. It also makes sense for me, coming back to a map after a few months, not remembering how things are set up, seeing the pieces that are near it really help. Technically, these could be anywhere in the map, right? But it's nice to have them nearby so you know what, that these are connected to this particular part of logic. So each pump is its own register, which actually I put next to the pumps. We have regimeter left and regimeter right for each pump. They start at 0. Each of these buttons will increase those registers by an amount, and that's actually more complicated than you think, and for a good reason. But we'll get to that. And then we have something that is taking the sum of those two registers, right? So this pump has pump left and pump right have their own registers. And then there's a register that's tracking both of them. I think it's this one. Yeah, it's the combination of the two. It's the sum of the two registers. So we want the goal of the puzzle, for lack of a better word, is to push both buttons down and have each pump be high enough in pressure that their sum total is higher than the threshold to open the door. Sometimes you can do it in one trip. Sometimes it takes 2. But when the player is standing on this button, they are increasing this register by an amount. But it's not just by a hard-coded amount. It's actually dynamic. But we'll get to that at the end because that's a little more complicated. Or it's not necessarily relevant to this logic. It's kind of an extra thing that we did for fun. So let's walk through one of these buttons here, and we're going to ignore the gauge readout stuff. That's kind of its own. That will be its own overview. Suffice it to say, we have the ability to read out a value of a register to a gauge in a few different ways, which we see in the map. Setting those up is its own process. It's not complicated. It's just that's what I would consider like the next level of logic in CPQ. So let's just focus on what's happening with the main pieces of the piece. So we have the button. It's targeting trig increment meter left, which is here, and it is updating the register, and it is taking the so our operation is 2, so we're adding the first register. Sorry, this one. We're adding the register left, so what's in the register, with the amount that we want to increase. So for now, let's just assume that it's 10. So we're basically we're adding what's in register left with 10. So all things being equal, the player stands on that button it goes from 0 to 10 to 20 to 30 to 40 to 50. Pretty straightforward. Hopefully. And then we are checking. Okay, so then there's so that's how we add it. We also have some timers here. And what these are doing, this one is for the meter, but this one is for decrementing these. Every second, each of these pumps goes down by 1 to a minimum of 0. That's what we're actually. That's why we have minimum values here. In some entities in CPQ, I have minimum and maximum values that can be enforced. It's usually through spawn flags where you say that you want to enforce it. I'll do a whole other series of videos about the various spawn flags as we get more dev time on CPQ, that they're all kind of locked in. So this is just be mostly focused on the logic part of it, not the names of fields and the flags that we use, just so people can start getting their head around this and start thinking about it. So yeah, so this timer every second will decrement left. We do the same thing for right. Every second it goes down. So presumably, if I stand on this button and this button is also every second. I stand on the button, the register goes up to 10, and then goes down by 1 to 9. Goes up to 19, goes down by 1 to 18, right? Because it's slowly leaking. That's the idea, is that as you're putting pressure on it, they're leaking. So the net result, even before we do anything else, is that because this gauge is a sum of the two things, we can actually see that, of the two pumps. We can actually see that here. This is also on a timer. This is the most timer-driven part of the showcase map. Maybe the boss fight has some more as well, but this is pretty timer-intensive. We have 5 timers happening here, maybe 6. 6 timers happening. Half of them are handling the gauges, but the other 3 are a timer for each pump going down, and then checking or setting the combination of the two, where it will add the value of left to right and store it in reg meter combo, and then it will check to see if that's greater than 180. So right, so each pump can go up to 100. The combo needs to be 180. So we're not quite making the player have them all up to max, because you couldn't quite do that. You would have to. You can't, right? Because by the time you get back over to one side, they would both have gone down by 2 every second, where it would be impossible to have them both max out. So we have some slop there to have it be doable for the player. And then, so the other kind of interesting kind of game design thing that we added to this, that the amount that we're adding to each pump is not a fixed value. It's what's in reg increase amount. Now, why are we doing that? Why don't we just have a set amount? Well, here, when you first enter, when you first get teleported down, you actually walk over these one-time triggers, because they're weight -1, so they only happen once. And what we're actually doing is we're setting the skill level that the player is using. We're setting that skill level, and we're putting that in a register. And then we're actually adding that. So reg increase amount, which I believe is here. Yes, so it's 15 to start, right? So every time, sorry, I was saying 10 before, it's actually 15. Every time the player steps on the button, by default, it will go at 15. But what we're doing here is we're actually taking that number, which is 15, and we're adding it to the skill level, right? So the result of that is, if you're playing on a higher difficulty, the amount, sorry, we're not adding it, we're subtracting it. We're subtracting it. So we're subtracting your skill level from the amount that it goes up. So it's 15 for easy, because that's a skill level 0. But as you go up in skill level, 0, 1, 2, 3, it adds less and less. So on hard or nightmare, it'll be -3. or even -4. I think Nightmare is 4. No, Nightmare is 3. Hardest to. Regardless, it will fill less as the player stands on it if it's harder. So what this is demonstrating is that you can use the skill level to tune how your logic works. If you want it to be harder because they're on a higher difficulty, this gives you the flexibility to do that, right? If you want to make the pumps take add less each time they press, if you wanted to make this the number that they have to reach to open the door be larger based off of the skill level, you could do stuff like that. This is kind of an example of how flexible CPQ could be for tuning the difficulty of a level. So that's the long and short of how this is set up. I did gloss over a few things, including the gauges, but the core logic should be there, and hopefully it's clear. Of course, after I post this in the comments of this video or on Discord, more than happy to answer questions and help people figure get through any confusion that they have with this, because it's a thing that I've been working on for a while, so it makes sense to me, but it might not be clear to everyone because it's kind of a specific way to do logic. It's very, because it's emulating a CPU. It is very nerdy. It is very in the weeds, but I think there's power in that, and it's very useful. So let's move on to the next piece. Okay, let's go back up to the ship of the player and actually talk about this map, because this will give us a chance to talk about how we use positioning in CPQ. So let's talk about how this is set up. We have two registers, the Y, so register intro target Y and register intro target Z. This was one of the first things that I set up, so this was before I was using the reg prefix, but it doesn't matter. Which relates to the Y and the Z of our target, right? Y being left and right, and from our perspective, and Z being up and down. So we're actually setting the Y and Z with these buttons. So each of these buttons is tied to an operator, where it will, in this instance, so let's go with left. So left will care about Y, so left will subtract Y, right will add, up will add Z, down will subtract it. And we see those operators here. So as we see here, we are subtracting it for the sub, we are adding it for add, and then adding and subtracting. Pretty straightforward. And actually what we're doing is we're adding 10. Each of these operators is just adding 10. So all that we're doing is changing the value of these two registers by 10 up or down. And we actually have a max value for the add, and a minimum value for each of these. So they can never go higher than 140 for Y. They can never go higher than 60 for Z. Then so that's pretty straightforward, but that doesn't actually do anything to this yet. All these buttons are doing right now is just adding and subtracting the values of the Y register and the Z register. What we're then doing is we're using those values. When they press one of these buttons, it sets the register. It will subtract or add accordingly, and then it will use that register. And this operation type is door position override absolute. The naming is a little weird. This is obviously not a door, but it is a func door. I won't get into the details as to why it is, but long story short, doors in Quake have a built-in ability to try and move to a position in relative space, a position in the world relative to where the door is. Because when a door opens, it already knows before that door opens the position in the game where it has to move to open the door. So we're actually taking advantage of that. We're actually exploiting that, and we're exploiting that by overriding where it's trying to go. Instead of where the game has pre-calculated where the door tries to open, we overwrite that by saying, no, go here instead when you open. And we actually have a spawn flag for that, which is the movement override. But again, that's pretty deep stuff. So we're actually using this 25 to do an override where it will, instead of where it wants to go, its new y will be the value of this register. So anywhere from 0 to 140. So now we've seen how we move this object. Each time you press one of the buttons for Y, it moves along the Y. Each time you press one of the buttons for Z, it moves along the Z, and it updates these two registers for that. Nice and easy. But let's talk about the teleporter. How does this correlate with how the teleporters work? These two teleporters work, actually. We actually have these series of expressions here. So this is for the first time that you triggered the side teleporter, but that's a feature. Actually, we can talk about that now. This works the exact same way for both the main teleport site and the secret teleport site. If we recall the playthrough, you learn about 6L, which is this position here on the map, as an alternate place to teleport to, and this just activates that. So what we're actually doing here, when the player presses the button to lock in the coordinates, it triggers this trigger right here. So what we're doing, there's the concept of enabling and disabling triggers in CPQ. I found not only does it make sense from a logic perspective, it actually makes things very tidy. If you want to turn triggers off, you don't always want them to be on. So what we're actually doing here, because we have two teleport triggers, the first thing that we do when the player presses this button is we turn both of these off. And that's what this is doing right here. Modify trigger is a CPQ entity. You can have multiple entities. We're actually piggybacking on this field, but we're targeting both the both teleporters and our teleport light, which is the red light when you have locked something in. We're turning all those off. That's the first thing we do. Second thing we do is then check the value of these two registers, the Z and the Y. And we've already seen things now where we can kind of see where this is going. Is this equal to 40? And is Z equal to 40? Is Y equal to 30? That's the first one here. We actually see this here. And then we have the side ones, which are 110 and 10, where when Y is 110 and Z is 10, that's when we turn on the side teleport. Otherwise, we turn on the main teleport. So we're seeing a pattern now of the general pipeline for setting up things in CPQ. You set a register with a value. In this case, we're setting the coordinates of the Z and the Y of this button, of us emulating the player setting up coordinates for teleporting. And then we're checking those values to see if they meet a particular set or a particular target. And then we're acting on that. In this instance, we're moving this object to a certain location, and then we're enabling or disabling a teleporter accordingly. I have some new entities coming up, probably not for version 2.2, maybe for 0.3, where we actually make this a lot more elegant, where we just have one teleporter and we actively change the target kind of midstream, where we don't have to stack a bunch of these. But that's for a later version of CPQ. So that's how the map room works and how the ship teleporter works. So let's go on to the next piece. Okay, so we've gotten through our door in the base. We've come down to this ramp where we had our ancient prisoners, the knights, locked in this sort of sacrificial cistern here, and we have this sort of blade, sort of emulating the blade of Damocles hanging over their heads, that track the player's position at the bottom of this ramp, and we can actually see that the driving trigger, the trigger that every two seconds this will kick off, and we have an array of entities. So let's kind of go through this. At this point, you might be able to guess sort of what's happening here, because if you saw through the playthrough, we're not only tracking the player's X and Y coordinates, also the Z, right? When the player jumps, the blade goes down. So we're actually doing X, Y, and Z, which is exactly what these three registers are for. The player's X, Y, and Z coordinates. You'll note that this trigger is actually quite tall, because if it was short, it wouldn't be catching the player as they're in midair, right? The player would be up here somewhere. We wouldn't be triggering, and thus it wouldn't be being saved to a register. So that's why it has to be tall. So it's still triggering while they're jumping. So we're setting each of those registers to that value. We do that just as we were before. Target position X, target position Y, target position Z. Then we're doing something interesting. So it's if anyone's worked with the concept of an offset, or I'm making something relative. So this is very finicky, and I already have some ideas about how to make this less specific. But currently, I have to hard code an offset. And here you can see what's happening. I'm doing an operator. I am subtracting the value in the register by a number and then storing it back in the register. So in this instance, I'm subtracting whatever's in here by 1464, 414, and negative 888. And what this is doing is setting a relative position for our blade, which is the object that we're changing its position of. We're setting it relative to that. If we actually look at its position, those numbers, yeah, we see where those numbers kind of come from, right? We can see its origin. It's very similar to what those numbers are. So every object in Quake, and this is a little kind of in the weeds. Most objects in Quake, doors especially, don't know their absolute position in world space. They know their relative position in world space. So if you ask a door, where are you in the world? It's like, oh, I'm at 0, 0, 0. Because that's where I'm supposed to be. I am at my position. It's not aware that it's actually, at 1400, 300, whatever. So we actually have to figure out what the relative position of the starting point of that door is to then tell it where to go. That's probably not super clear, and I'll do more documentation on this. But basically, we have to tell this object, this door, that it needs to move relative to where it started, not to a specific position in world space. So that's why we subtract these hard-coded numbers from it, which makes it relative. So if the player, and we do one more thing here, we do a fourth operation, which is to multiply the z by -1, the z by -1. And we do that because we want to actually invert the blade. Stop it. Oh yeah, the blade based off of the player, right? If the blade was going exactly where the player was, it would be up here with them, right? It would go up to them and actually push into them and do damage. But we want it to go down when they go up, so that's why we actually multiply it by -1. That's inverting it. So the z will be the opposite of what the player is doing. And then we just use register to override it, like we did with the target on the teleport map, and that's it. And then we have the puzzle here being is that you need to kill these 6 knights. These are using just normal Quake triggers up to a counter. Once they're all dead, the door opens. This was one that I spent some time working on. That would be a fun way to show tracking player position in a puzzle form. I had some other ideas that I didn't want I don't want to lean on other CPQ entities to track. Like I didn't want it to do like distance. I wanted to use Quake physics, and there's nothing quite like squishing enemies in Quake. It's a very satisfying, very old school thing that you do in Quake. So that felt fitting. So yeah, killing those 6 knights will open the door, and let's go inside and unpack these other pieces. Okay, now we've gone through the door, and we're in this main room. And this time we're going to look at the side logic pieces first before we talk about the main progression. So over here we have this sort of platform where when the player first walks on it, this door opens and some enforcers show up. But what we're actually doing here is this is also showing how we can change states on the player. There's no actual register here. It's just two use registers, actually. which we've already learned don't necessarily need a register to do anything. They simply impact the player or another entity. So we have two triggers. We have the one on the ground that the player will trip when they're walking around. Then we have the one that's on a platform. So these have been arranged intentionally so they can only really touch one at a time, right? They can touch the one on the floor, they can touch the one in the middle. They'll never be able to touch both at the same time, which is good, because the one on the floor here will use the take armor, basically. So that will set the player's armor to 0. If we look at the operation type, player armor, count is 0. Very straightforward. But why are we doing that? We're doing that because in the middle, we're actually doing a what's called, the trigger is called grant armor, where we're actually setting the player's armor to 200. So we're doing this every second, because that's the wait time on these triggers. And the idea here is to show that, and that's actually why these enforcers show up when you first start getting the armor, is that you can kind of see the impact of what is red armor mitigation, right? If you're at 200 armor, that's very high armor. You're taking a lot less damage, and then it's refreshing it. We're also actually playing. It's a little misleading, but I didn't want to spend too much time digging up custom sounds. But it actually plays the pentagram sound, the item in Quake that makes you invulnerable, every second when it gives you the armor, to at least tell you that something's happening. So that's why we then set your armor to 0 when the player leaves. Obviously, this isn't a great tool like game design wise, because you don't really want to ever set the player's armor to 0 on your level, because presumably you'll give them armor somewhere else. And we actually address that a little bit later. But this is more to show that you can impact the player's state, and this was one of the states that we hadn't really interacted with. We did health earlier, and we'll do ammo here shortly. So that's this logic piece. Let's go over to the other. All right, so let's go over to the other piece of logic on the side that we set up. We have the pit, and we actually have our console with the riddle that the cheeky little riddle that we gave. In the pit, you must bleed 50 pints, then proceed. Just gives the player a little hint about what's happening down here. So we have three registers that are used during this process. Let's first talk about what's happening, or what happened in the playthrough. Player falls down into this little pit. It's all red and scary. The zombie throws their brains at them, and once the player takes a certain amount of damage, the door underneath them opens up and they fall down and get a mega health. So we do this through 3 registers. We have the register that records the player's starting health. So this trigger volume here is what starts that off. So here we can actually see operation type target health. Since we have no target, it's the player. We set their health to this register here. So we know that there's no way that the player can't walk through this trigger to get down here. So we're going to get their latest health when they do so. So they're actually landing on a set register trigger. So this is actually the first part of the logic loop that will happen down here. So they land on and activate this set register, and this also takes their health. And this is going to give their current health to a second register, which is current health. So we have the first register, which is tracking their health when they started, and we have a second register, which is tracking their current health. And then this trigger is linked to a operator trigger. And what it's doing is it's subtracting their starting health from their current health. So we want to figure out how much damage they've taken since they've been down here. And it's actually putting the result of that in a third register, the damage taken register. And then this links to the Boolean expression. And as you could kind of guess at this point, we're looking to see how much damage they've taken. Once it's greater than or equal to an amount, we trigger the door and down they go. You'll notice that the amount is actually 40, not 50. It was 50 initially, but 40 ended up feeling more fair through playtests. So now that we've seen down here, let's go look at the main part of the room. Okay, so we're back in the main room, and we have the main logic piece to look at here, the charging battery. So the console tells us that we need to bring 56 volts to this battery to charge it to open the door. And we do that by bringing it the cells ammo that we find throughout the level. And this is done through 2 registers and 5 triggers, 6 triggers actually, if you include the driving one. So we have the player cells, a register that we've set for that. And then we have the energy stored. So we are storing the current number of cells that the player has and the current number that the player has stored in the battery. The first trigger, the driving trigger, sets the current number of cells the player has. And then we do an expression. We check that register to see if it's greater than 0, basically, if they have any cells. If they do have cells, then we print the extracting message, the extracting cells message. If they don't, then we say 56 volts required. Then, if it's true, we then continue to the operator, which reduces the register that has the current cells, right? So let's say that we walk up to the trigger, we have 40 cells, it records that number in the register. We then subtract that by 1. So this is operation type 3, so we're subtracting it by the count, which is 1, and then storing it in the same register. So what we're doing is you walk up with 40 cells, it records 40, and then it subtracts 1 and makes it 39, and puts that back in the same register. The next trigger in the chain then sets that amount to the player for the amount of cells they have. So this is kind of a roundabout way of taking 1 cell away from the player. So, and we actually see here in the operation type 11 is that's how many cells they have. So they walk up, they have 40 cells. We take the number, we store it, we subtract 1 from it. We then set that many cells to the player for how many cells they have. Then we add 1 to the stored cells, a register, which is the energy store, right? We have that here. The operation value is 2. We are adding 1 to that. So we take 1 away from the player, and we add 1 to the total being stored. And then we, of course, check that to see what that number is. If it's greater than or equal to 56, we open the door. So, and there are other entities here that deal with the digital readout, but we're not going to get into those because those are a little more complicated and kind of beyond the scope of this overview. So that's how we open the door. Let's go into the door and start talking about the last few pieces of the map. Okay, so we're through the door and we're into the next area where we have a couple CPQ pieces to talk about. At the bottom of these ramps, we have this Keycode entry with another display. And the player got pieces of the Keycode through these consoles, just not super complicated, just a little bit of logic to kind of put it together that this is the Keycode here. So there's only one register, that is the Keycode itself. And then we have these operators that each of these buttons are tied to. And they all do the same thing. The type of operation that we're doing here is what I call a value build. Effectively, if you imagine that you're like in an old school calculator or any kind of Keycode entry, let's say that you only have 5 numbers and you put in 1, 2, 3, 4, 5. If you put in a 6th number, we want it to go to the first place and push all the other numbers to the left, right? So you're not clearing it. You just keep putting in numbers until it's the value that you like. That's the easiest way. I don't want to have the player have to clear them or hit 0 or something. So that's what value build is in CPQ when we're talking about building a number. And each of these buttons is tied to an operator that just adds that number to the register. So we have 0, 1, 2, and 3. As I said in my playthrough, I didn't do more numbers because I didn't really want to clog the space up with 10 different buttons. But it, of course, supports that, right? It's just passing a number into it, so it could very easily be any of the 10 digits. Then of course we set the readout, and of course the logic there is a little more complicated, and we aren't getting into that. And then we do the kind of same thing that we've been doing always, is that we do an expression. We check to see what the value of the Keycode register is. If it's 31220, access granted. We print the message, we trigger the door, and that door opens up to the boss. This isn't really worth going in its own segment. This is just how we activate the teleporter here. This button just basically enables this trigger. We talked earlier about turning triggers off and on. This just turns this trigger on and turns the light on so the player can go back to their ship. And we'll talk about the secret that reveals as our last part. But let's go to the next piece. Okay, so we have the last piece that we're going to talk about before the boss fight. This is the sort of the bigger secret, I guess, in that it requires the player to figure out that 6L is one of the coordinates that they can put in the ship, and that will lead them here. There's no actual logic happening here other than just opening this wall and giving them some cells. But it's what we do with the ring here, the ring of invisibility, or the ring of shadows, as it's called in the game. So we put this here quite prominently, actually, so the player grabs it. So if we saw in the playthrough earlier, there was this this lift here that when they press the button to activate it, it says the shadows beckon from below. And this is a hint that they should try and use this lift while they have the ring. And if they do that, the lift will go down instead of up. Let me actually do it down instead of up, revealing access to armor. So how this is done is through one register, and this is we call this player invis. And when they hit the button, when they hit the button, we're actually checking something. We're recording their items' bit flags into this register. So in Quake 1, the items that a player has is a number. It's a single number. However, it is the sum of the bits of the items that they have. And I won't go too technical into this, but for example, the shotgun is 1, the super shotgun is 2, and so on. So just through one number, you can bit flag and through that to see what items they have. And that includes power-ups. If you get the ring, if you get the pentagram, if you get the quad, you get the biosuit, that all changes your bit flag number. So we're recording that number here in the register with this set register trigger that happens when they press the button. Then it's just a matter of checking that number, right? I know that the invisibility item is 524288. That's the bit that is flipped when the player has that. So we just check to see if this number has that bitwise and in it, and if it does, we actually change the lift itself, the door. It's interesting. We haven't really talked about changing the states of non-player entities, but here is an example of that. The operation that we're doing is door platform angle. We're actually changing the angle at which this door moves. By default, it's set to -2, which is up in Quake terminology. A -2 is up, and I've messed up this brush a little bit, but yeah, a -2 is up. But if we look at the Boolean, if it's true, if the player does have the Ring of Shadows, we set its angle to -1, which means that it goes down instead of up. And that's it. And if they don't have the Ring of Shadows, it sets it to 2. So every time the player presses that button, it checks their items' bit flags, sees if they have the Ring of Shadows. If they do, it changes the angle of the door to go down. If they don't, it changes the angle of the door to go up. And that's it. And there's actually some really neat things you can do with doors. We actually have other that we don't show off in the map, but we can modify basically most of the main elements of door: its lip, its speed, its weight, and that can be very interesting to tweak those on the fly in a map based off of player activity. And that's that. So let's get to the boss encounter as our final overview. All right, so here we are in the boss encounter of CPQ Showcase, where the player is fighting this rogue AI that we call Damocles. This is going to be a fairly complicated overview, so I'll actually be splitting this up into a few different sections. So let's start with the overview of the fight, and then we'll dig into each part of the fight. So as you saw in the playthrough, player walks in, these plates start opening up. They actually open up randomly. It's actually very randomly, which is cool. There's no deterministic way to predict which door will open. These doors open, and they reveal a energy cell the player has to attack with the lightning gun. As they do that, the health of the boss goes down, and they have to do that 3 times. We have these 3 phases, and then once they get to the second phase, this pusher starts activating and trying to push them off the ledge. And of course, if they do that, they fall on the acid, and then they get teleported back up top. So the sort of the very broad game design goal here was to require the player to be fairly nimble at dodging this. They need to be accurate with their aim, because these plates close every so often, and ammo is limited. So the only way to get ammo is this this kind of recharging station that only recharges every 10 seconds or so. So it requires the player to be careful with their ammo, to watch what's happening, and in the third phase, after they do enough damage a second time, these plates drop, and then there's these exposed wires that are surrounding these cells. And if the player shoots these, then that will do damage to the player, sort of like trying to model the energy being reflected back at the player for not being accurate. And then once they do that a third time, the boss is defeated, the door opens, and they can go back to their ship and go home. So let's talk about this in stages, and I'll actually keep these brushes exposed so we can reference them later. There are a few pieces to this. Let's talk about the large piece first. That is the health of the boss. We have yet another way of displaying information here with this slider gauge. It works as you would expect, and behind the scenes, basically, we have the max health and the current health of the boss. We know its full position, and we just slide it down to 0 based off that percentage. So we have a bunch of registers. There are actually, let's see, I believe 4, 5, 6 registers, 7 that we use for this boss fight. So let's dig into boss health. So we have the current boss's hit points, starting at 1500, and its max hit points. We do this so we know what where to put the slider, because the logic needs to know what percentage of its health it is. And also we need to know what to set it back to for every stage. And at the end of this, I'll kind of go through some ideas that I have that you can make this harder. This wasn't supposed to be super hard or that challenging. It might be for some players. I don't know. We'll see when I put the map out soon and get some feedback. But it wasn't intended to be hard. It was more intended just to show all these things moving at once and how they could be used to make an encounter. So we have the boss's current health, boss's maximum health. We also have the phase of the fight. There are 4 states, actually, 4 states that the fight can be in. It's in phase 1, phase 2, phase 3, or it's over. And we actually track this here with this register. It starts off in phase 1. So each of these cells actually has the same filtering we saw earlier in the map when we talked about the button that you could hit only with the axe. We're doing the same thing here with the lightning gun, which is the bit 64. However, we're doing something else here. We're also this has also been added in CPQ, is the ability to directly take damage applied to a button and either set it to a register or modify a register, right? So what we're doing here is we've set that, and we've also added the subtract damage instead of set. And then we've made the button have infinite health, so it will never actually trigger. There's no actual trigger for this button. All this button does is take damage and pass that damage onto a register, which we've put here as regboss HP. and then it will actually subtract it. So whatever damage this thing takes, it subtracts from the boss's health, and thus is our only way of doing damage to the boss. Is player damages this only with the lightning gun because we've added that filter, and if they have, then damage gets the boss's health gets reduced. So we have this main trigger here. This trigger multiple that I've called a trig boss tick, and there's a good reason I've done that, because this is effectively the tick of the boss fight. You would be astute in noting that it does not tick while the player is falling down the acid. That's fine, because if they're falling down, there's no way for them to get back up, and they'll be back up shortly once they teleport. So that's fine. I could technically make this trigger be the whole height of the room, but there's not really a point to that. So this trigger is actually doing quite a bit, and we'll step through the things that it's doing. The main thing we have some relays here that are accepting the trigger. We have one relay which will set the slider of the health based off of the current health, and then we have an expression to check the boss's health. And that is this series of triggers here. The first one is quite straightforward. What is the boss's health less than or equal to 0? I.e., has the boss taken enough damage to go to 0? If it has, then now we increase the phase. Right, we're adding 1 to the boss phase. Then we check to see what phase we're in. And that's what this series of Boolean expressions is. Each one is checking if we're now in phase 2, if we're now in phase 3, and if we're now in phase 4. Each of these have triggers that are hooked onto them if we are in that phase. For example, if we are in this phase, if we just started phase 2, we unlock or we enable the other trigger that we'll look at shortly that drives the pusher, as we're calling it. If we're in phase 3, we take off the covers on the cells. We expose those, and we also do some things with the lights to make it kind of scary. And if we're in phase 4, that means the fight is over. We print a message to the player that the fight is over. We do a sound that explodes, and we open the door so they can leave. We have these hooks on phases 2 and 3 that are operators that are taking the register of the max health, which we have, and taking that value and setting that to the current health. So basically, it will reset the boss's health back to full, whatever value is here, after phases 2 and 3, because as we saw in the fight, boss takes enough damage to hit 0, it resets back up to full, and we go to the next phase. So that's what's happening here. Let's go to the pusher. So in phase 2, the pusher is unlocked, and it will routinely try to knock the player off. That's actually being driven by a second trigger that's beneath the main tick. This was because I didn't want to. I just wanted one trigger to enable when it was time. I didn't want to have to keep checking if it was phase 2, or phase 2 or 3. I just wanted a trigger that was just dedicated to that. I also wanted that wait to be different, right? The wait time of this trigger is 4 versus the wait time of the main trigger is 0.4. I only wanted this to be happening every 4 seconds, and we actually see that during the fight. Every 4 seconds, the pusher finds the player position, goes forward to push them off, and then resets. And we accomplish that up here with this series of logic. And as you've seen, I try and keep the logic separated when I'm doing this. It helps a lot to relearn how I set it up if I've been away for a while, or at some point when other mappers are looking at these maps to understand how certain bits of logic are grouped together. So we have two registers that handle this. We have the player's X. So all that we care about here is the player's X position, where they are and left to right on this platform, basically. And then we have the pusher X, which will be the value that we actually set. So the the tech that we're using here is very similar to the tech we saw with the teleport target button, with the floating blade and the soldiers. It's the same thing. We are figuring out where to move a brush, in this case a door. So this is being driven by this multiple trigger that is only enabled in phases 2 and 3. It's setting the register of the player's current X, as we've seen before, target position X. So it sets that to player X. It then does the offset because, as we saw, we need to offset our doors so they are in relative space versus world space. So I've derived that 3096 is where this brush starts, or its origin that we care about is. And then we use that, where we will use that value, and in this operation, when we offset it by 3096, we're storing that in the pusher X register, which is the second one. Technically, you could use the first one if you wanted to be more efficient, but I used to. So then, once we have that offset, we apply that offset to the brush. With these same methods that we've seen before, we're just overriding its position. And then so we're doing something a little extra here, though. There are two different ways that we can set a brush's position. The first is relative, which we saw is relative to where the brush started in the map. Then we have absolute, which is will attempt to set the brush to a world position. And we're actually doing that here, where we're telling it to change its Y to be negative 300, and its Y being if you're facing it front and back. But we do this. The timing of this is such is that it will only do that after the 4 seconds, where because we're actually triggering it. After we set the X of the pusher and the Y that the absolute Y that it needs to go to, it starts where the player is. It sort of tracks the player, and then once it's hit that 4 second mark, it will open, as the door does, to that Y position, and then return. And actually, when you play, you can actually see that when it opens to where the player is. Let's pretend that this is the player. It opens to where the player is, but if the player is moved since it's pushed out, the pusher actually retracts back to the player's X, because it's always keeping track of what that X is, or every 4 seconds, right? So if the player has moved somewhere else in those 4 seconds, let's say it was extended out to here, and then 4 seconds pass, or the next tick passes, it will track back to where they were. So it's a neat effect. Obviously, it's not too hard to avoid this once you know what to look out for when you're playing. But I thought it was a really cool way to show how you could use player position as an element during a boss encounter. So the last piece to talk about is up here, and that is the plates. So during the fight, and this is also driven by... Actually, this is actually a timer. Right, yeah, sorry. There are so many pieces to this, I forget sometimes how it was set up. This is actually a timer. This is just every 4 seconds. It will open a plate. And these plates, there are 7 total. If we hide... I don't want to hide the trigger, I'll just delete these. If we see... We have 7 plates. So 7 cells that can be shot, because the 8th is being used by this massive yellow computer tech square. So we have 7 possible plates, and every 4 seconds we derive that, or we pick one and open it. How do we do that? So we have the operation type 20, which is a random number, which is one of the operations that you can do when you set a registers. You can do a random number. You can do. I have an option for an int or a float. Technically, in Quake, all numbers are floats, but I want to give the option to treat it as an int, so it wouldn't do any decimals. And then you can basically tell it what you want the number to be between. So we have our minimum and our maximum. So I want a number, an integer, a whole number between 1 and 7, meaning one of my 7 plates. And then this is the only time that this is a newer entity that I've used, which I call a target hub, where basically I have, which is basically a splitter. I have all the different brush names 1 through 7 for door plate, door boss plate 1 through 7, and I basically will align those to based off the value of a register, right? So we pick a number between 1 and 7, and we set that to this register, and then target hub will look at that register, and based off of the number inside of it, will trigger the appropriate plate. So if we hit register, we randomly select register 4. This will then check that, go to readout 4, trigger that brush, and then that's it. So that way we get one of the 7 plates opening every 4 seconds, and it's completely random. There's no deterministic way, at least within the realm of how Quake C can do random numbers, determine how that which plate will be open. So that's the boss encounter. There are obviously lots of utility things here and there, about triggering the lights and the charging station, but that's the meat of the boss encounter. All right, well, thank you so much for watching. I hope this has been a useful overview of the systems of CPQ. We learned how CPQ works on a broad level. We played a map that was set up using CPQ entities, and then we went through the map in an editor and saw how they were all set up. And hopefully with all this information, this should give you a really good idea about how CPQ works, and more importantly, how it might be used in maps. The goal of this is to start getting mappers thinking about CPQ as an option for their maps, and really start thinking about the broad ways that they can use this advanced logic in their maps to make things a lot more interesting, to do puzzles, to do boss encounters, to make the map really feel more dynamic, and more in line with some of the in-game logic that we see in more modern games. It's a goal of mine to see Quake evolve, and I think lots of mappers also have this goal, is to really push the engine to its limits of what it can do. And I think CPQ is an exciting way to try and do that. So CPQ is in active development. It's my goal to have a new version out by the end of the year. It'll be version 0.2 that will more or less have all the entities that we have looked at during these 2 videos, and a few more that we haven't. It will have documentation. It will have both a website with all the entity references as well as a PDF. It will have all the map source for both Showcase and my other kind of test maps that people can look at and play with. I'm hoping to do a mapping jam at some point in the near future, once people have gotten their heads around the idea of CPQ and get people excited to try and kick the tires. I really intend for this to be driven by how the community wants to use it. I want to get this in as many hands as possible, get people trying to make maps with it, give you some feedback on things that are working, things that aren't. It's my intent to make this an active development that's using the Quake community to drive its direction. So if you're interested in mapping or CPQ, I'll link to the Quake mapping Discord that I spend a lot of time on. Also put a link to Dump Truck's awesome Quake mapping playlist on YouTube. He has a ton of videos about Quake 1 mapping that anyone who's interested, both beginner and expert, should definitely watch. They're extremely useful to learn how to map in a modern environment. So look for that below. And of course, links to CPQ itself, and that's where I'll put all the news as things come out. Thank you very much for watching these videos. I hope they were informative. I hope you have a better idea about what CPQ is. If you have any questions or comments, please reach out to me on Discord. I'll put my handle in the description, or write in the comments below. Thanks for watching.